Hello students, so today we are going to see the basic waveforms, or we are going to see how to draw the basic waveforms of amplitude modulation, phase modulation and frequency modulation. So in communication, in analog modulation, basically these three types of modulations are frequently used. So what happens in amplitude modulation? In amplitude modulation, the amplitude of the carrier signal changes in proportionate with the amplitude of modulating signal, whereas the frequency and phase of the signal remains constant. So that is the concept of the modulation. So already we have seen how to draw the diagram of FM and PM. But just I will revise as per your demand. Just I am revising it quickly, and then we will go for diagram of amplitude modulation. By taking some sinusoidal signals, we will draw that particular waveforms of AM signal. So first we will draw the diagram of FM. So for any modulation process, we require two signal. First one, it is the modulating signal, and another one, it is the carrier signal. So the difference between modulating signal and carrier signal is that always the carrier signal is having more frequency as compared with the modulating signal. So this is the carrier signal that I am drawing. So let us, when you are drawing the diagrams, or when you are drawing the signals in your graph paper, that proper divisions or proper scales you have to take. So what is that care that you have to take? That I am telling amplitude. First point, it is amplitude. Amplitude is there on y-axis. That's why we are representing here as V. On x-axis it is T. Similarly, here it is T. Here it is V. So I am explaining you how to draw the diagrams with proper scale and what care you have to take when you are going to draw a particular signals. Diagram we have seen, but by considering scales, what proper care you have to take, that I am explaining in this diagram specifically. So modulating signal, whatever is this amplitude for positive half cycle, that should be same for the negative half cycle. Then whatever is the time period of this positive half cycle, same should be there for the negative half cycle. That another care you have to take. So modulating signal frequency, it is noted by FM. So always you have to write here what is the value of this frequency. Let us say it is value 1 kilohertz, that you are supposed to write. Again on y-axis, voltage, whatever is there. Now another concept related to voltage you have to understand. When we say for any signal, when we say that its amplitude is 3 volt, suppose I am saying that amplitude of the signal, it is 3 volt. So what is its meaning? For positive half cycle it is plus 3 volt, and for negative half cycle it is minus 3 volt. So whenever amplitude of this signal is 3 volt, पीक टू पीक व्होल्टेज, आपण जेव्हा वेवफॉर्मचे रीडिंग्स घेतो तेव्हा आपल्याला पीक टू पीक व्होल्टेज नोट डाऊन करावं लागतं. सो पीक टू पीक व्होल्टेज इज इक्वल टू 2 into amplitude of the particular signal. So what will be peak to peak voltage for this particular signal? That will be 2 into 6, that is 6 volt peak to peak. That thing also you have to remember when you have to take the readings. So here it is represented as voltage, or here it is also represented as the amplitude, and here on x-axis it is represented as time. This is positive and this is negative half cycle. Again carrier frequency is noted by FC. So considerably the carrier frequency should be far greater as compared with the frequency of the modulating signal. That care you have to take. So this is the another point that you have to remember. Now we will draw the waveform for FM signal. Now you understand what is the difference in this capital FM signal and whatever FM is written here. So this small FM represents frequency of the modulating signal, whereas this capital FM represents frequency modulation, that is representing the frequency modulation waveform. So in FM what happens? For this positive half cycle, frequency of the signal it is more, and for negative half cycle, frequency of the signal it is less. So it will be drawn like this. For positive half cycle, frequency of the signal is more. So if you take the projections, for positive half cycle the frequency is more, and for the negative half cycle frequency is less. That is the concept of the frequency modulation signal. So here the frequency is less and here the frequency is more. So again here it will be T on x-axis and here it will be voltage on the y-axis. That is the concept of FM. Now if you see, whatever is the modulated signal, it is having all the parameters same as the carrier signal except the parameter which we are going to change in the modulation. For example, if we consider the amplitude modulation, amplitude of the carrier will only change, all other parameters will remain same. If we consider frequency modulation, frequency of the carrier signal will change, all other parameters remain कॉन्स्टंट. आता इथं फक्त फ्रिक्वेन्सी चेंज झालेली आहे मॉड्युलेटिंग कॅरियर सिग्नलची. त्याचं ॲम्प्लिट्यूड जे आहे इट विल बी सेम ॲज द कॅरियर सिग्नल. अगेन इट्स फेज इज ऑल्सो सेम ॲज द कॅरियर सिग्नल. देर इज नो चेंज इन द फेज. दिस इज द डायग्राम ऑफ FM modulation. Then the another type of modulation we are going to consider, that is the phase modulation. So what is done in phase modulation? If we are considering, first is the modulating signal, it is having the less frequency. Then in continuation with that, I am drawing here the carrier signal. Suppose this is the carrier signal which is having more frequency as compared with this modulating signal. Then in phase modulation what happens? The points where the cycle is changing from positive to negative, त्याचे आधी प्रोजेक्शन्स घेऊन ठेवा खाली ह्या वेवफॉर्ममध्ये. Particularly when we are drawing the waveform of phase modulation, we have to take, whenever we are drawing the diagram of phase modulation, we have to take projections of the positive half cycle and the negative half cycle. So here it is positive, here it is negative, here it is positive, negative. So here are the 3 points where the positive to negative transition is taking place. You have to take its projections, and at that projection only phase of the particular signal is changing. So for example, if you consider the diagram for phase modulation, how we have to draw? Again here it will be time, here it will be voltage, here also it will be voltage, here is also voltage. So for positive half cycle it will travel in the same path. आता ह्या पॉइंटला जेव्हा फेज मॉड्युलेशन नसतं, at that point it is traveling as it is. It will continue the path of analog signal. But when the phase modulation takes place, specifically there is change, or there is phase change by 180 degree. So instead of traveling in the or continuing in the same way, it is changing its phase. So that is the concept of phase modulation. Similarly here if you consider, this point if you consider, if modulation is not there, it will continue in the same way. पण आता इथं मॉड्युलेशन होतं आहे म्हणजे काय होईल हा पाथ? हिअर इट विल टेक 180 degree change and it will be traveling in the particular direction. So when phase modulation we are considering whatever are the points where the cycle changes from positive to negative or negative to positive. At that point there is difference in the phase of the particular signals. Okay, so phase it is changed by 180 degree. So already I have explained, if you consider any analog signal, from start to end. This is having 0, this is having 180, then this is having 360, it is having 90, and it is having 270. So phase shift it is from 180. म्हणजे हा पॉझिटिव्ह हाफ सायकलचा जो निगेटिव्हला जाणार आहे तो निगेटिव्हला न जाता काय होतो, ॲज इट इज इट विल कंटिन्यू, अँड इन निगेटिव्ह instead of going to positive it will again continue to the negative. That is the concept of the phase modulation. So I hope that is clear. Now we have seen yesterday the waveforms for amplitude modulation. So we have seen the 3 types of amplitude modulations: under modulation, exact modulation, and over modulation. So how to draw the waveforms for these particular type of modulations, that we will see. So that basic thing we have seen for under modulation and over exact modulation. So by taking reference of that, first we will see how to draw the diagram for over modulation. So there are 3 types: under modulation, exact modulation, and over modulation. So if we consider the over modulation in AM, what is the condition that we have to consider? This Vm should be greater than Vc. Whatever is modulation index that is greater than 1, so this Vm is greater than Vc, that we have to consider. So let us consider that the Vm is equal to 2 volt and Vc is equal to 1 volt. Let us consider Vm is equal to 2 volt and Vc is equal to 1 volt, and you take Fm is equal to 1 kilohertz and you take Fc is equal to 20 kilohertz. So always this Fc value should be greater than the Fm value. So by considering this, we have to draw the graph for the over modulation. So we will take the scales. What signal I have to draw first? I have to draw the modulating signal. So what is the voltage of modulating signal given? Vm is given as 2 volt and Vc is given as 1 volt. तो चेंज आपल्या डायग्राममध्ये दिसला पाहिजे. So this Vm is equal to 2 volt and this Vc it is equal to 1 volt. So I will write here, this is 2 volt plus this is minus 2 volt, plus 2 volt and minus 2 volt. This is Fm. Fm is equal to 1 kilohertz and here it is having voltage. Now second signal you have to draw, that is what? Carrier signal. So what is amplitude of carrier? 1 volt. So here it is plus 1 volt, here it is minus 1 volt. So let us first draw here the carrier signal, which is having frequency more as compared with the modulating signal. Okay, this is carrier signal. Fc is equal to 20 kilohertz. This value is equal to plus 1 volt and minus 1 volt. Now how to draw the graph of AM signal, that we will see. Now we are considering the equation voltage of AM signal. Voltage of AM signal is given by Vc plus instantaneous value of Vm. So what is the difference in this capital Vm and this small Vm? Capital Vm ची व्हॅल्यू फिक्स आहे. कॅपिटल Vm म्हणजे it is nothing but the amplitude of the signal, and small Vm means it is instantaneous value of the particular signal. So this small Vm is the instantaneous value of the signal which is changing at each point. So here it is 0, here it is 0.5, here it is 1, 1.5, 2, 1.5, 1.5. Here it will be negative, minus 0.5, minus 1, minus 1.5, minus 2, like that. So everywhere this small Vm is having the different value, and capital Vm is amplitude which is fixed as 2 volt for this particular signal. So by considering these equations, how you have to draw the graph for over modulation? that I am explaining. So VAM will be equal to VC. What is the value of VC? 2 plus the first what I told you, in the diagram of AM, always initially draw two dotted lines in positive side and negative side which are having the same amplitude that of the carrier signal. कॅरियर सिग्नलचं जेवढं ॲम्प्लिट्यूड आहे तेवढ्या ॲम्प्लिट्यूड एवढ्या दोन डॉटेड लाईन्स आपल्याला पॉझिटिव्ह हाफ सायकलला काढायच्यात आणि निगेटिव्ह हाफ सायकलला काढायच्यात. सो दिस इज फर्स्ट डॉटेड लाईन अँड दिस इज द सेकंड डॉटेड line. So that lines we have to draw first. After that, whatever are these respective voltages that will get added with each other. म्हणजे amplitude modulation मध्ये हे amplitude आणि हे amplitude those are adding with each other. That's why it is written VAM is equal to VC plus VM. So at every point this frequency of the carrier is remaining same, phase is also remaining same, फक्त amplitude change होता. Now let us say one by one. At this point, suppose let us say this is point X and this is point Y. मग ह्या दोन्हीचं combination consider करून what value I will get here for this amplitude modulated signal? VAM is equal to VC plus VM. VC ची value 2 fix आहे. What is the value of this VM at this point? So VAM at point X is equal to 2 plus 0, so that is equal to 2 volt. So our waveform starts from 2 volt. Then what is the value of VC here? It is equal to 1. So VAM is equal to 1 plus 0, that is given as 1 volt. VAM is equal to 1 plus 0, that is given as 1 volt, which point it is given here. Then for this particular point, let us say this is point Y. So how you will calculate value of VAM at point Y? VAM at point Y is again given by VC plus what is the point voltage at point Y. So what is the voltage at point Y? It is 0.5. So it is equal to 1 plus 0.5, which is equal to 1.5 volt. So let us say it is here 1.5 volt. Next, X, Y, Z point you consider. So VAM at point Z, it is given as VC plus what is the amplitude at this point Z, that is equal to 1. So in that case it is 1 plus 1 is equal to 2 volt. So it will be like this. Then 1.5, that is the X is 0, Y is 0.5, Z is 1, having amplitude as 1. Then let us consider some another point P, which is having voltage as 1.5. हा इथला point consider करा, which is having the voltage as 1.5. So how you will find out VAM at point P? VC plus काय येईल इथं 1.5. So it will be given as 2.5. So amplitude of VAM at this point is 2.5. And then next the value it is, next the value, let us say this is point Q. So at point Q the voltage is equal to 2 volt, or this modulating signal is having the value as 2 volt. So how you will find out the VAM at point Q is equal to VC plus 2 volt, that is equal to the voltage as at point Q will be 3 volt, that is it will be continued like this. Again for next point it will be like this. म्हणजे याचं प्रोजेक्शन इथं येतं आहे. सो ॲज इट इज आपला मॉड्युलेटिंग सिग्नल इथं रिपीट होतो. नाव दिस इज अबाउट द पॉझिटिव्ह हाफ सायकल. पॉझिटिव्ह हाफ सायकलमध्ये दोन्ही व्हॅल्यूज पॉझिटिव्ह आहेत. सो दॅट्स वाय दिस ॲम्प्लिट्यूड इज ग्रेटर दॅन 1 or this is greater than 2. Now what will happen for this negative half cycle? What values are there in this negative half cycle? These are the values as minus 0.5, minus 1, minus 1.5, minus 2, minus 1.5, minus 1, minus 0.5 and 0. So these values are going to be minus. So for negative half cycle, values of Vm are going to be negative. So for negative half cycle, the values of Vm are going to be negative. So how you will calculate? Let us say this is a point. Here it is point A. Aचा amplitude आहे आपण consider केलं आहे minus 0.5 volt. So at point A, how you will calculate Vam, or I will write here Vam at point A. How you will calculate? Vc plus Vm. So it is Vc is equal to 1 volt plus minus 0.5. So it will become as 1 minus 0.5 which is equal to 0.5 volt. म्हणजे इथं आपल्या AM सिग्नलचं ॲम्प्लिट्यूड किती आलेलं आहे 0.5 volt. नेक्स्ट जेव्हा ह्याची व्हॅल्यू 1 volt आहे, लेट अस से दिस इज पॉईंट B. So at point B this value is minus 1 volt. So how you will calculate value of Vam? Vam at point B will be given as Vc plus Vm. So it will be 1 plus minus 0.1, that is equal to 0. That is the concept of this AM graph for under modulation for negative half cycle. Negative half cycle ला काय होईल? Vm ची व्हॅल्यू निगेटिव्ह आहे, त्यामुळे Vam सिग्नल इज ऑल्सो हॅविंग द ranges in the negative. Okay, so Vam at point B is equal to 0. Now let us see point C. The amplitude of point C, so amplitude of point C is minus 1.5 volt. So in this diagram, if we see, amplitude of this point C is minus 1.5 volt. So how you will calculate the value of Vam signal at point C is equal to 2 plus minus 1.5. So it will be given as 2 plus minus 1.5. So what is the value of carrier signal? 1 volt. So it will be given as 1 plus minus 1.5, or I will write here once again Vam at point C. Okay, so Vam at point C is equal to Vc plus voltage of that modulating signal at point C. So what is here? Vc is equal to 1 plus C point ला किती आहे याची व्हॅल्यू minus 1.5. So it is equal to minus 0.5. So in that case it will come to this side. So this signal will come towards this side. So it is having voltage as minus 1.5, or it is having voltage as minus 0.5. Then Vam at point D we will calculate. Now let us say this is point D, and voltage of this signal at point D is equal to minus 2 volt. At point D, what is the voltage of this signal? It is minus 2 volt. So Vam signal at point D is equal to Vc plus instantaneous value of this modulating signal at point D. So how it will be calculated? Vc is equal to 1 plus minus 2. So here this value is equal to minus 2. So it will be given as 1 plus minus 2. म्हणजे इथं टोटल व्हॅल्यू किती येईल याची minus 1 volt. So for this, the signal is again going into the negative half cycle, which is given as, which is having value here as minus 1 volt. हा ह्या पॉईंटला झाला. पुढं काय होणार आहे परत, हा -2चा इथं आहे 1.5, इथं आहे -1, इथं -1.5, here it is -0.5. so whatever are these values, those will go on in the reverse. so हा जर पॉईंट आता आपण ई बघितला तर ईची व्हॅल्यू किती आहे -1.5. म्हणजे त्या केसमध्ये VAM, so just I am writing, not all calculations, VAM at point E will be equal to 0.5. then VAM EF, let us say this is G and H. so VAM at point E is equal to 0.5. VAM at point F is equal to how much it will be, 1 plus -1, so it will be equal to 0. then VAM at point D, E, then F, VAM at point F will be equal to 1 plus -0.5, so it will be equal to 0.5. म्हणजे हा सिग्नल इथून परत तुमचा काय होतो, इन दिस डायरेक्शन इट इज गोइंग. सो ओव्हरलॅपिंग ऑफ दॅट टू सिग्नल्स इट इज टेकिंग प्लेस इन केस ऑफ ओव्हर मॉड्युलेशन. हा एवढा 1 व्होल्टचा जो पोर्शन आहे, दॅट पोर्शन इट इज कमिंग इन द निगेटिव्ह हाफ सायकल. सो सिमिलरली दिस साइड what will happen, mirror image of that we have to take. so here it will travel up to this, and here it will be coincident, and again it will travel in the same way. so this is the concept of the over modulation. over modulation मध्ये overlapping का होतं, because the value of VM is greater than VC, आणि VM ची व्हॅल्यू VC पेक्षा जास्त असल्यामुळं our basic equation is VAM is equal to VC plus instantaneous value of this modulating signal. so as this VC value is less as compared with this VM value, that's why we are getting some voltages in negative, and these two signals are overlap. so you can try the diagram for over modulation condition so that it will be more clear to you. so you take some values. So for example, you take the value of VM signal as 3 volt, you take the VC is equal to 2 volt, and draw the diagram for over modulation. Try to draw the diagram for over modulation. Again, you take the VM value as 4 volt, VC value as 3 volt. Try to draw the diagrams for over modulation. so like this, if by taking the calculations, if you are trying to draw that the waveforms, the concept will be more clear to you. otherwise, if we have to draw the combinedly the 3 diagrams, जर मग आपण ग्राफ बघितला AM मॉड्युलेशनमध्ये 3 केसेसचा, तर तो असा असतो. एक्झॅक्ट मॉड्युलेशनमध्ये काल सांगितलं मी तुम्हाला, व्हॉट हॅपन्स इन केस ऑफ एक्झॅक्ट मॉड्युलेशन, इट विल बी like this. so signals are coincident with each other. this is the graph of exact modulation. how it is there for under modulation? in case of under modulation, it is like this. so they are having some distance from the x-axis. this is the graph for under modulation. and if we see the diagram for over modulation, in that case the diagram for over modulation, it is given as like this. so some overlap is taking between the positive signal and the negative signal. हा जो आहे इथं हा पोर्शन, that is indicating the mixing of two signals or overlapping of these signals. So in this way the three diagrams are drawn for under modulation, over modulation and the exact modulation in amplitude modulation system. Okay, so you take some values of under modulation, exact modulation and over modulation. So otherwise you can do the practice for drawing this waveform by taking the respective values of Vm and Vc. दोन्ही जर सेम घेतल्या तर that will give you the exact modulation. If Vm is greater than Vc घेऊन बघा, त्याच्यामध्ये तुम्हाला over modulation मिळतं. And if Vm is less than Vc, in that case you will get the under modulation diagrams. So you try to take the different values and practice the respective diagrams so that the concept will be more clear. And in again here at center whatever is there, that is nothing but the carrier signal, or whatever is the frequency of this AM signal, that is same as that of the carrier signal. So this frequency, it is same as that of the carrier signal. So this is about the three basic concepts of AM modulations. Okay, thank you.